Guys and girls, here's a second example of balancing an equation where I'm going to use shapes and colors to help me keep track of how many elements I have on each side. This is a more complicated equation than the last one, but we can use the same strategy that we did before to actually make it balance. Again, the whole idea behind having an equation balanced is I have the same amount of each element on the left-hand side as I do on the right-hand side. And I'm going to use different colors and different shapes to help me keep track of how many of each I have. And this is particularly helpful if just numbers don't make as much sense to you, but colors do, like you can see things visually much better. So it looks like I have one FE. I'm just going to randomly pick a square and color it red for FE. And then on this side, it looks like I have three FEs. So I'm going to draw three red squares for that. Now on the left-hand side, I'm going to do H. Looks like I have two H's, so I'll use circles for H. And I'm going to use the color black, and I'm going to draw one for each, so two overall. And then on the right-hand side, it looks like I have two H's as well. So two black circles to represent two H's. And now finally, I have to represent oxygen. I'll use blue for that, and say I'll use a triangle for that. It looks like I only have one oxygen here, so I'll do one blue triangle. And on this side, I've got four oxygens, so I'm going to draw four triangles. Okay, so now that we have everything diagrammed out, I can see what things I'm missing. It looks like oxygen, I'm missing some of those, and iron, I'm missing some of those. Pick one element at a time to try make balanced. Don't try to do multiple elements at a time because then you just end up getting lost in the numbers. So I'm going to pick iron. It doesn't matter which one you pick. I just pick that one at random. Looks like I have three irons on this side, only one iron on this side, so I got to put a 3 in front because I need to triple the amount of iron I have. So I'm going to draw now. Every time I update my coefficient, I'm going to update my diagrams down here. So 3 times 1, 3 FEs, so I have 3 red squares. Looks like my FEs match up now. My hydrogens match up now. My oxygens don't, so I need to take care of that now. I have 1 oxygen over here. I have 4 on my right-hand side, so I need to quadruple the amount of oxygen on this side. In other words, I need to do 1 times 4 to make it equal. The only problem is the only way I can make oxygen equal is I have to put a 4 in front of this entire compound, which means I need to multiply all of this by 4. The hydrogen and the oxygen, they're a package deal. If I want more oxygen, I need to take more hydrogen with it. They're stuck together. So now I have 4 times 1, 4 oxygen, so I'm going to diagram that out. And 4 times 2, 8 hydrogens. So I'm going to go back to my black circles, since that's what I chose to represent hydrogen, and diagram that out as well. So now it looks like I have the same number of oxygen on each side, the same number of iron on each side, but I'm missing a whole bunch of hydrogens. I've got 8 over here. Looks like I only have 2 over here. Well, 2 times what equals 8? Turns out that's 4. So I'm going to put a 4 in front of that. And again, I'm going to update my diagram. So I now have 4 times 2, 8 hydrogens. And now as I look at my diagrams, my hydrogens look balanced, my oxygens look balanced, my irons look balanced, my equation is now balanced. So this is how to use the same strategy to balance a more difficult equation.